Welcome, traveler, and rest here at the edge of time's infinite tapestry. Whether you arrive burdened by the weight of ticking clocks or soothed by the rhythm of your own breath, lay down your haste now. The universe has been unfolding for 13.8 billion years. It will wait a little longer for you to find stillness. When you gaze at the night sky, do you feel time's vastness pressing gently against your fleeting existence? Does your mind ever linger on the paradox that the starlight caressing your eyes tonight departed its cosmic home long before human civilization began? You are about to embark on a journey where seconds stretch like taffy near black holes, where time runs backward in quantum equations, and where your morning coffee cools in perfect accordance with the same thermodynamic laws that guide stars to their graves. We're not merely telling time tonight. We are unraveling its very fabric. From the attosecond precision of atomic clocks to the glacial ticking of continental drift, from the frozen present of a photon's perspective to the warped chronology near a neutron star's crushing gravity, time reveals itself to be not a rigid ruler, but a fluid melody played on space-time's curved instrument. What does time mean to you in this moment? The impatient blinking of your bedside clock? The relentless scroll of calendar pages? Or something more mysterious? The universe's way of allowing cause and effect to unfold like a flower's petals. However you conceive of time's passage, I invite you to release those notions now, as we prepare to explore realities where time loops like a Mobius strip, where the now you cling to is as fleeting as a bubble in a stream. First, take a moment to tell us, what time are you joining in on this journey? Is it quiet and late where you are, with a dark and starry night? Or is the sun just rising from the horizon, stretching its beams to light across the distances? The equations we'll wander through are not cold abstractions, but love letters from the cosmos. Einstein's curved space-time, quantum mechanics' tangled timelines, the thermodynamic arrow that gives time its direction. Here, in the quiet space between wakefulness and dreams, you'll discover that a day is never just 24 hours, but a dance between Earth's rotation and your brain's perception. That your memories are not recordings, but living stories, rewritten with each recollection. That your very atoms remember ancient stellar explosions that first forged their existence. So breathe deeply, in and out, and let the boundaries between physics and poetry dissolve. Let the glow of your screen become the warm light of the cosmic microwave background, the afterglow of creation itself. We're about to contemplate a reality where time slows near massive objects, like syrup pouring in winter, where entangled particles communicate outside conventional time, and where your consciousness may be the universe's way of experiencing its own temporal unfolding. The equations can be intricate, but the essence is luminous. Time is the medium through which the universe explores its own possibilities. And in this hour, you become the universe contemplating itself across seconds and eons. A perfect harmony. Shall we begin our journey? Fear not, we'll proceed as gently as dawn's first light stretching across a planet's curve. Like a leaf carried on time's river, we'll drift from quantum scales to cosmic horizons, until the distinction between clock time and live time begins to blur. The most profound truth is this: time never truly passes. It lingers in the wrinkles of space-time, hums in the vibrations of atoms, whispers in the synaptic pathways of your remembering mind, and it waits, always waits, for you to notice its quiet miracles. There is something soothing about the way time surrounds us, an invisible embrace that cradles every moment of our existence. It is the quiet rhythm of our heartbeat, the slow dance of shadows across the floor as the sun moves through the sky, the gentle turning of pages in a book as we lose ourselves in its story. Time is both the most familiar and the most mysterious force in our lives. We measure it, we chase it, we mourn its passing, yet few of us pause to consider what it truly is. Not just the numbers on a clock, but the very fabric in which the universe unfolds. Imagine yourself sitting by a window on a rainy afternoon. The droplets trace winding paths down the glass, each one moving at its own pace, some hesitating before joining others in their downward journey. Outside, the world seems to slow. The leaves tremble in the breeze, a bird alights on a branch, and for a moment, everything feels suspended, as if time itself has softened. This is the illusion we often experience, that time is constant, uniform, unchanging. But the deeper truth is far more wondrous. Time breathes. It stretches and contracts like the tides, flowing differently in different places for different observers. It is not a rigid framework, but a living, shifting dimension, as fluid as the river of Heraclitus, into which no one ever steps twice. From the earliest moments of human consciousness, we have sought to understand time. Ancient civilizations watched the heavens, tracing the cycles of the moon and the sun, marking the seasons by the tilt of the stars. They built stone circles and obelisks that cast long shadows, turning the sky itself into a clock. The Egyptians divided the night into 12 hours, though their length changed with the seasons. The Babylonians gave us the 60-minute hour, a system so elegant it has endured for millennia. And yet, for all their ingenuity, these early timekeepers were measuring only the surface of something far deeper, the way time manifests in our world, not its fundamental nature. It was not until the 20th century that we began to glimpse time's true character. Albert Einstein, with his theory of relativity, revealed that time is not separate from space, but woven together with it into a single continuum, space-time. Picture a vast silken sheet stretched taut, with the stars and planets resting upon it, creating dips and curves. A marble rolled across this sheet would follow the contours, just as planets orbit the sun, not because of some invisible force, but because the sheet itself is warped by the sun's mass. Time, too, is warped. Near a massive object like Earth, time moves more slowly than in the emptiness of space. A clock on a mountaintop ticks ever so slightly faster than one at sea level. An astronaut orbiting the planet ages a fraction of a second less than those of us on the ground. These differences are tiny, almost imperceptible in our daily lives, but they reveal a breathtaking truth. Time is not absolute. It is as malleable as clay, shaped by gravity and motion. Consider two identical clocks, one placed on a high-speed train, the other standing still at the station. When the train returns, the moving clock will show slightly less time has passed. This is not a defect in the clock, it is time itself slowing down for the traveler. The faster you move through space, the slower you move through time. At speeds approaching that of light, time would nearly stop. This is the heart of relativity. The universe has a speed limit, the speed of light, and as you approach it, time bends to ensure nothing exceeds it. The cosmic ledger must always balance. Yet, for all its flexibility, time has a peculiar stubbornness. It flows in one direction. We remember the past, but not the future. A shattered glass does not reassemble itself. A candle burns down, but never back up. This is the arrow of time. a mystery that has puzzled philosophers and physicists alike. Why does time move forward? The answer lies in a concept called entropy, the measure of disorder in a system. The universe tends toward greater entropy, greater disorder, and it is this tendency that gives time its direction. Imagine a drop of ink falling into a glass of water. At first, the ink is concentrated and ordered, but soon it spreads, diffusing until the water is uniformly tinted. This is entropy increasing, and it is irreversible. The ink will not spontaneously gather back into a droplet. In the same way, the universe began in a state of exquisite order, the Big Bang, and has been unraveling ever since, time riding the wave of that unraveling. But what if we could step outside time? What would it look like from the perspective of a photon, a particle of light? To a photon, traveling at light speed, time does not pass at all. From the moment it is emitted to the moment it is absorbed, its entire existence is instantaneous. A billion-year journey across the cosmos is, for the photon, a single frozen moment. This is the strange, dreamlike nature of time at the extremes of physics. As we prepare to delve deeper into the warping of time, the possibility of time travel, the mind-bending implications of quantum mechanics, let us pause here in this quiet space of understanding. Time is not just something we measure. It is something we inhabit, like a vast and silent ocean, its currents carrying us forward in ways we are only beginning to comprehend. Close your eyes for a moment. Feel the rise and fall of your breath, the steady pulse of your heart. These, too, are measures of time, as intimate as they are universal. Long before clocks ticked and digital displays flashed numbers, humanity first became aware of time through the silent, majestic movements of the cosmos. Picture our earliest ancestors sitting around fires under endless starry skies, watching the moon wax and wane in its eternal cycle. They saw how the sun's position changed with the seasons, how shadows lengthened and shortened each day. These celestial rhythms became humanity's first timekeepers, written not in numbers, but in stone, myth, and memory. The great obelisks of ancient Egypt, towering monoliths of polished granite, were among our first attempts to capture time's passage. As the sun traveled across the sky, the obelisk's shadow would creep across marked stones on the ground, dividing the day into measurable segments. These early sundials were more than practical tools. They were sacred bridges between earth and sky, between mortal lives and the eternal cycles of the heavens. The Egyptians noticed something profound. Time was not linear, but cyclical. The annual flooding of the Nile, the predictable return of constellations, these patterns suggested that time moved in great repeating circles. Meanwhile, in the British Isles, Neolithic builders were constructing Stonehenge, aligning massive stones with celestial events. On the summer solstice, the rising sun would perfectly align with the heel stone, flooding the center of the circle with golden light. This was more than a calendar. It was a temple to time itself, where the movements of the heavens were made tangible on Earth. The builders understood that human time was but a small part of cosmic time, and they sought to harmonize their lives with these greater rhythms. The Babylonians took timekeeping further, developing sophisticated mathematical systems based on the number 60, a choice that still echoes in our 60-minute hours and 60-second minutes. They tracked the motions of planets with astonishing accuracy, creating clay tablets that recorded celestial events centuries into the future. For them, time was not just measurement, but prophecy. The movements of the heavens were messages from the gods, a divine clockwork governing human affairs. In China, the water clock, or clepsydra, marked time's flow with quiet precision. Water would drip from one vessel to another at a steady rate, measuring hours through the night when sundials were useless. The sound of dripping water became the heartbeat of monasteries and palaces, a liquid metronome counting out the moments of civilization. These clocks were often beautifully ornate, with floating indicators and mechanical displays, early attempts to make the invisible visible, to give form to time's formless passing. The medieval monastic world developed a different relationship with time. In monasteries across Europe, the canonical hours, matins, lauds, prime, terce, sext, non, vespers, compline, structured both prayer and work. The ringing of bells became the soundtrack of daily life, calling monks to prayer at set intervals. This regimented timekeeping was not about efficiency, but about spiritual discipline, the regular reminder that all time belongs to God. The mechanical clocks that later adorned cathedral towers grew from this monastic tradition. Their gears and weights translated celestial motion into audible chimes. As we reflect on these ancient timekeepers, we begin to see how our understanding of time has always been shaped by both practical needs and profound wonder. The earliest calendars were attempts to predict seasons for planting, but they were also maps of the sacred, ways to connect human lives to the grand movements of the universe. The steady improvement in timekeeping technology, from shadow clocks to water clocks to mechanical clocks, represents not just technical progress, but an ever-deepening conversation with time itself. What's remarkable is how these ancient perceptions still resonate today. When we look at a modern atomic clock with its cesium atoms vibrating billions of times per second, we're still pursuing the same essential goal as the builders of Stonehenge or the Babylonian astronomers: to align ourselves with time's fundamental rhythm. The methods have changed, but the longing remains: to understand our place in time's vast flow. As we prepare to explore how this understanding deepened with the scientific revolution, let's pause to appreciate these early timekeepers. Their legacy surrounds us still, in the circular faces of our clocks, in the names of our months, many honoring Roman gods, in our continued fascination with celestial events. They remind us that time is not just something we measure, but something we experience, something that connects us to the cosmos and to all the generations before us who likewise looked up at the stars and wondered. Let's continue our journey through time's unfolding story. The next chapter awaits, where we'll witness how Galileo's pendulum and Newton's absolute time transformed humanity's relationship with the fourth dimension. As dawn breaks over 17th century Italy, a young Galileo Galilei kneels in the Cathedral of Pisa, his attention captured not by the Mass, but by a swinging chandelier overhead. The bronze lamp sways back and forth with hypnotic regularity, its arc gradually diminishing, yet each swing taking precisely the same amount of time. This simple observation, that a pendulum's period depends only on its length, not the width of its swing, would revolutionize humanity's relationship with time. The universe Galileo realized contained within its ordinary motions a perfect timekeeping mechanism, if only one knew how to listen. The story of time's measurement enters a new phase with the invention of the pendulum clock in 1656 by Christian Huygens. Picture this elegant device, a heavy bob suspended by a thin rod swinging with metronomic precision, its steady tick-tock like the heartbeat of the universe itself. For the first time, hours could be divided into minutes, and minutes into seconds with unprecedented accuracy. The pendulum clock didn't just measure time, it made time's passage tangible, audible, something that could be held in the mind's ear, even when the eyes were closed. Clocks became centerpieces in homes and town squares, their rhythmic voices synchronizing human activity with newfound precision. Yet this mechanical revolution in timekeeping coincided with a profound philosophical shift. Isaac Newton, gazing at the same night sky that had mesmerized the Babylonians and Egyptians, conceived of time as absolute, a universal river flowing at the same rate everywhere, unaffected by the motions of earthly things. In his Principia Mathematica, Newton described time as mathematical and perfect. Quote, absolute, true and mathematical time, of itself and from its own nature, flows equably without relation to anything external. End quote. This vision of time as an immutable backdrop against which the universe's drama played out would dominate scientific thought for centuries. The 18th century brought ever more precise timekeepers. John Harrison, a self-taught English clockmaker, devoted his life to solving the longitude problem, how sailors could determine their east-west position at sea. His marine chronometers, perfected after decades of tireless work, kept near-perfect time even on rocking ships and through tropical temperature changes. These brass-bound masterpieces, with their intricate balance wheels and temperature-compensated mechanisms, shrunk the world by making ocean navigation precise. Timekeeping became not just a scientific pursuit, but a matter of life and death for sailors and of imperial power for nations. Meanwhile, in workshops across Europe, clockmakers achieved new levels of miniaturization. Pocket watches, once the exclusive privilege of royalty, became accessible to the growing middle class. These personal timepieces changed how people experienced their days, no longer governed solely by the sun's position or church bells, but by the hands moving across a private dial. The very concept of punctuality emerged from this democratization of time measurement. People began to speak of wasting time or saving time as if it were a commodity that could be managed. The Industrial Revolution accelerated time's transformation of society. Factory whistles replaced church bells as the markers of daily rhythm. Train schedules necessitated standardized time zones, ending the era when each town kept its own local solar time. In 1884, at the International Meridian Conference, the world was formally divided into 24 time zones centered on Greenwich, England, the first global synchronization of human timekeeping. The clock tower became the symbol of modern civilization, its face visible across expanding cities, its chimes audible above the noise of steam engines and bustling commerce. Yet even as mechanical clocks grew more precise, scientists were uncovering hints that Newton's absolute time might not tell the whole story. Astronomers noticed curious anomalies in Mercury's orbit that couldn't be explained by Newtonian physics. The speed of light, measured with increasing accuracy, appeared constant, regardless of the observer's motion. These were the first ripples suggesting that time might be more mysterious, more fluid than the steady ticking of pendulum clocks implied. The pendulum swing thus marks a pivotal moment in our story, the transition between ancient cyclical time and modern linear time, between celestial timekeeping and mechanical precision. Those brass clocks with their oscillating weights represent more than technological achievement. They embody a new way of being in time. The universe, we began to believe, ran like clockwork, predictable, measurable, controllable. But as we'll discover in our journey ahead, this orderly vision was about to be profoundly challenged. When Albert Einstein rode his famous thought experiment about chasing a beam of light, he would shatter Newton's absolute time and reveal a universe where time bends and stretches like warm taffy. The pendulum's perfect swing, it turns out, was just the beginning of the story. For now, let the rhythmic tick-tock of imaginary pendulum clocks lull you into that peaceful state between waking and sleeping, where time seems to soften and stretch. In this quiet space, we can almost hear the echoes of all the clocks that ever were, from water dripping in ancient clepsydra to the precise vibrations of Harrison's marine chronometers, each one whispering secrets about time's true nature. On a quiet afternoon in 1905, a young patent clerk in Bern, Switzerland, dared to imagine riding alongside a beam of light. This simple thought experiment would unravel humanity's most fundamental assumptions about time. Einstein, gazing out his office window at the trolley cars moving through the city, realized something astonishing. Time does not flow at the same rate for everyone. The ticking of clocks depends on how fast they're moving and how close they are to massive objects. Time in Einstein's revolutionary vision became elastic, stretching and compressing like the breathing of some great cosmic being. Picture two identical clocks, one placed on a high-speed train, the other resting on the station platform. As the train accelerates to nearly the speed of light, a remarkable thing happens. The moving clock begins to tick more slowly compared to its stationary counterpart. This isn't a mechanical defect, it's time itself, bending to accommodate the universe's ultimate speed limit. The faster an object moves through space, the slower it moves through time. At light speed, time would stop completely. A photon of light, from the moment it's emitted to when it's absorbed, experiences no time at all. Its entire existence is a single, frozen instant, regardless of whether it travels across a room or across the universe. This phenomenon, called time dilation, becomes even more pronounced near massive objects like stars or black holes. Imagine two twins. One stays on Earth, while the other travels to orbit a neutron star. When the spacefaring twin returns, they would have aged less than their Earthbound sibling. Gravity's intense pull near the neutron star would have stretched time like taffy, making clocks run noticeably slower in its presence. Near a black hole's event horizon, time slows to such a crawl that an outside observer would see a falling object appear to freeze in place, its image reddening as light waves stretch toward infinity. Einstein wove space and time together into a single fabric called space-time, a four-dimensional continuum where massive objects create indentations like bowling balls on a trampoline. These curvatures explain why planets orbit stars. They're simply following the natural contours of warped space-time. Time becomes inseparable from space, a dimension we move through just as surely as we move through length, width, and height. Your morning commute to work isn't just a trip through space, but a journey forward through space-time at the speed of light. The implications ripple through our understanding of reality. GPS satellites must account for both types of time dilation. Their high speed make their clocks run slower by about 7 microseconds per day, while Earth's weaker gravity at their altitude make clocks run faster by 45 microseconds. Without these relativistic corrections, GPS locations would drift by kilometers within hours. Even your smartphone's navigation depends on Einstein's stretching time. As we drift deeper into these revelations, consider how they transform our experience of the present moment. When you look at the stars, you're peering into the past. The light from Alpha Centauri left its surface over 4 years ago. The Andromeda galaxy appears as it was 2.5 million years in the past. The night sky becomes a mosaic of different eras, a cosmic time machine built into our very eyes. There is no universal now. What you perceive as present depends entirely on your frame of reference. This relativity of simultaneity shatters Newton's conception of absolute time. Two events occurring simultaneously for one observer may happen at different times for another moving at relativistic speeds. The sequence of events isn't fixed. Only events that can be connected by light or slower signals maintain consistent order. The past, present, and future become fluid concepts, their boundaries determined by perspective rather than decree. Yet for all this flexibility, time maintains one stubborn directionality. We remember the past, but not the future. Eggs scramble, but never spontaneously unscramble. This arrow of time points unerringly toward increasing entropy, the universe's tendency toward disorder. All the stretching and warping in the world can't make time run backward on large scales. The second law of thermodynamics stands as time's gatekeeper, ensuring causality flows in one direction as relativity makes time malleable. As we prepare to explore time's behavior in the universe's most extreme environments, black holes, the Big Bang, and perhaps even wormholes, let's pause to appreciate Einstein's revolutionary gift. He showed us that time isn't a backdrop, but a participant, not a stage, but a dancer in the cosmic ballet. The ticking of clocks becomes a local dialect rather than a universal language, each one telling its own story of time's passage. Close your eyes and imagine space-time as a vast, tranquil sea. Your life is a boat moving across its surface, creating ripples that stretch into the future. Nearby boats may share your experience of the waves, but those moving at different speeds or in stronger currents will feel time's rhythm differently, yet all are carried forward by the same cosmic tide. At the edge of a black hole, time ceases to behave in any recognizable way. Imagine a cosmic hourglass where the sand stops flowing altogether. This is the fate of time near these gravitational behemoths. As we approach this ultimate frontier, all our familiar notions of seconds, minutes, and hours unravel like threads in a cosmic tapestry. Here, in the shadow of the universe's most mysterious objects, we encounter time in its most alien form. Picture an astronaut falling toward a black hole, feet first. From their perspective, time flows normally. They might check their wristwatch and see the seconds ticking away at their usual pace. But for observers watching from a safe distance, something extraordinary happens. As the astronaut nears the event horizon, the point of no return, their movements appear to slow down. Their last approach to the horizon stretches to infinity. Their image dims and reddens as light struggles against the black hole's gravity. From the outside perspective, the astronaut never quite crosses the horizon. They become frozen in time, a permanent silhouette on the edge of oblivion. This phenomenon reveals a profound truth about our universe. Time is not just relative, as Einstein showed, but can become infinitely dilated. Near the event horizon, the gravitational time dilation becomes so extreme that time effectively stops. The black hole's gravity warps space-time to such a degree that the future direction for anything inside the horizon points inevitably toward the singularity at its center. There is no path that leads back out, not just in space, but in time. The singularity doesn't just lie ahead in space, it lies ahead in time. The mathematics suggests something even stranger. At the very center of a black hole lies the singularity, a point where density becomes infinite, space-time curvature becomes infinite, and our laws of physics break down completely. Here, time as we know it may cease to exist entirely. The singularity isn't just a place in space, but the end of time itself for anything that crosses the horizon. Some theories suggest all paths in the black hole's interior lead to the singularity the same way all paths in our future lead to tomorrow. Yet, black holes aren't the only places where time behaves strangely. The Big Bang presents us with a mirror image of this temporal mystery. Just as black holes represent potential endings of time, the Big Bang appears to have been a beginning. Run the cosmic film backward, and we see the universe contracting to an infinitely dense, infinitely hot point where time itself may have begun. What came before the Big Bang may be as meaningless as asking what's north of the North Pole. Time, in our familiar linear sense, may have been born in that primordial explosion. These extremes of cosmic beginning and end force us to reconsider time's fundamental nature. Perhaps time isn't an inherent property of the universe, but emerges from deeper quantum processes, like temperature emerging from the motion of molecules. Some quantum gravity theory suggests that at the most fundamental level, time may be discrete rather than continuous, flowing in tiny indivisible chunks of about 10 raised to the power of negative 43 seconds. Below this scale, the smooth space-time continuum we experience may dissolve into quantum foam, a seething, chaotic realm where time has no clear meaning. The mystery deepens when we consider wormholes, theoretical shortcuts through space-time predicted by Einstein's equations. If they exist, and that's a big if, traversable wormholes could in principle allow time travel to the past. But nature seems to have safeguards against paradoxes, perhaps through quantum effects that prevent wormholes from becoming time machines, or through the Novikov's self-consistency principle, which suggests any time travel actions must form consistent loops without contradictions. As we contemplate these temporal extremes, we find ourselves facing profound philosophical questions. Is time truly fundamental, or is it an illusion emerging from deeper physics? Why does it seem to flow in one direction when the fundamental laws of physics are time-symmetric? Could different regions of the multiverse, if it exists, experience time differently, or not at all? For now, let these mysteries wash over you like the gravitational waves rippling through space-time from distant cosmic collisions. Imagine floating at the edge of a black hole's event horizon, watching time slow to a standstill. Or picture the first moments after the Big Bang, when time itself was new, and the universe fit in a space smaller than an atom. These extremes show us how limited our daily experience of time really is, how the steady ticking of clocks masks a far stranger, more wondrous reality. Our journey into understanding time brings us to the quantum realm, where particles can affect each other across time and causation becomes fluid. Ahead lies the boundary between relativity and quantum mechanics, a frontier where time may behave in even more mysterious ways. We proceed to the quantum tapestry of time. Beneath the smooth flow of seconds and minutes lies a hidden realm where time behaves unlike anything in our everyday experience. In the quantum world, time becomes fluid, reversible, and strangely interconnected, a dimension where cause and effect dance to different rules. Imagine a cosmic loom weaving reality not in straight lines, but in endless loops and sudden jumps, where the very concept of before and after begins to blur. This is time at the quantum scale, where the universe reveals its most enigmatic secrets. At the heart of quantum mechanics lies the wave function, a mathematical description that encapsulates all possible states of a particle until the moment of measurement. This wave function evolves smoothly and predictably according to the Schrödinger equation, a process that treats time as reversible. Unlike the arrow of time we experience in the macroscopic world, quantum equations work equally well whether time flows forward or backward. A video of quantum interactions would look physically plausible played in reverse, a stark contrast to our everyday world where broken eggs never spontaneously reassemble. The measurement problem introduces time's first quantum paradox. When we observe a quantum system, the wave function collapses instantaneously to a definite state. This moment of quantum transition appears to happen outside ordinary time, a sudden jump rather than a smooth transition. Some interpretations suggest this collapse happens faster than light, seemingly violating relativity's cosmic speed limit. The act of measurement creates a peculiar relationship with time. The past, the superposition of states, abruptly gives way to the present, the measured reality. Quantum entanglement adds another layer of temporal mystery. When two particles become entangled, their properties remain correlated regardless of distance. Measuring one particle instantly determines the state of its partner, even if separated by light years. This spooky action at a distance, as Einstein called it, suggests a deeper level of reality where time and space don't constrain connections between particles. Some interpretations propose that entangled particles aren't communicating faster than light, but rather that their correlation reflects a fundamental timelessness at the quantum level, as if the measurement outcomes were predetermined in some higher dimensional reality. The transactional interpretation of quantum mechanics offers perhaps the most radical view of quantum time. It proposes that quantum events are settled through handshakes across time, with waves moving forward and backward in time to complete transactions. In this view, when an electron jumps to a lower energy state and emits a photon, the process involves advanced waves, moving backward in time, from the future absorber of that photon. Time becomes a two-way street at the quantum level, with future events helping determine present outcomes. Quantum gravity theories attempt to reconcile this with Einstein's spacetime. In loop quantum gravity, spacetime itself is quantized, woven from tiny, indivisible loops at the Planck scale. Time in this framework becomes granular rather than continuous, like the individual frames of a film. The illusion of continuous motion in a movie arises from still images flashing rapidly. The holographic principle suggests an even more profound reorganization of time. It proposes that all the information in a volume of space can be encoded on its boundary, like a cosmic hologram. In this view, time in the interior may emerge from timeless quantum correlations on the surface. Our experience of temporal flow could be akin to watching a movie projected from data encoded at the edges of reality. As we approach the limits of current physics, we encounter theories where time may not be fundamental at all. In the Wheeler-DeWitt equation of quantum cosmology, an attempt to quantize general relativity, time disappears entirely from the formalism. The universe is described by a timeless wave function that simply is, with our experience of time emerging from correlations between quantum states. This timeless universe interpretation suggests that time as we know it is a kind of persistent illusion, a useful fiction created by our limited perspective. Yet for all these abstract theories, quantum time has practical manifestations. Atomic clocks, the most accurate timekeepers ever built, rely on quantum transitions in cesium or rubidium atoms. Quantum coherence, the maintenance of superposition states, forms the basis of emerging quantum computers. Even photosynthesis in plants appears to exploit quantum coherence across femtoseconds, suggesting nature has been harnessing quantum time long before we understood it. As you drift towards sleep, imagine the universe as a vast quantum tapestry, where every moment contains echoes of past and future, where particles dance to rhythms spanning all time, and where the distinction between then and now becomes beautifully blurred. The steady tick-tock of your bedside clock masks a far more mysterious temporal reality, one we're only beginning to comprehend. Would you like to continue our exploration to the cutting edge of temporal physics, where scientists are testing whether time is truly fundamental or merely emergent? The next chapter awaits at the frontier of quantum experiments and cosmological observations that may rewrite our understanding of time's nature. Just say the word, and we'll proceed together into this unfolding mystery. We take a deeper look into the nature of time, we now arrive at a revolutionary possibility that time may not be fundamental to the universe at all, but rather something that emerges from more basic components, like consciousness emerging from neural networks or temperature emerging from molecular motion. This radical reconceptualization invites us to imagine a timeless foundation of reality from which the river of time gradually coalesces, much like the flow of a river emerges from countless molecular interactions. The concept of emergent time arises from attempts to reconcile quantum mechanics with general relativity in theories of quantum gravity. In these frameworks, time disappears from the fundamental equations, leaving only timeless correlations between quantum states. The Wheeler-DeWitt equation, developed in the 1960s as an attempt to quantize Einstein's theory of gravity, famously contains no time variable at all. It describes the entire universe in a single, frozen moment, a cosmic photograph where past, present, and future exist simultaneously in some higher dimensional reality. This timeless perspective finds echoes in ancient Eastern philosophies. Buddhist teachings describe time as a conceptual construct, while Hindu cosmology envisions the universe as the divine play, Leela, where time is merely part of the performance. Modern physics now arrives at a similarly counterintuitive view through mathematical rigor rather than spiritual insight. The flow of time may be like the movement of a rainbow, apparently real from our perspective, but ultimately revealed as a trick of position and perception. Yet, we undeniably experience time's passage. How does this illusion emerge? One compelling explanation comes from quantum entanglement and the growth of quantum correlations. As particles interact and become entangled, their quantum states become interdependent in ways that create a directionality, what we perceive as the arrow of time. The universe began in a state of minimal entanglement, the low entropy Big Bang, and has been growing increasingly entangled ever since. This growth of quantum connections provides the scaffolding upon which our experience of temporal flow is built. Thermodynamics offers another perspective on emergent time. The second law, that entropy always increases, gives us our most robust arrow of time. But at the microscopic level, individual particle interactions are time-symmetric. The emergence of thermodynamic time resembles how a casino always wins at roulette despite each spin being fundamentally unpredictable. The house advantage emerges from countless interactions, just like time's arrow emerges from countless quantum events. Remarkably, biological systems seem to have evolved mechanisms that exploit this emergent nature of time. Circadian rhythms, our internal biological clocks, operate through complex biochemical networks that maintain roughly 24-hour cycles, even in isolation. These biological oscillators don't so much measure time as create it, generating temporal order from molecular chaos. Similarly, our brains construct the experience of temporal flow by integrating sensory inputs at different latencies, creating a specious present that stitches together what is essentially a series of discrete perceptual moments. Cutting-edge experiments are now testing these ideas about time's fundamental nature. Quantum physicists can create time crystals, strange quantum systems that show periodic structure in time rather than space, breaking time translation symmetry. Cosmologists search for subtle patterns in the cosmic microwave background that might reveal traces of pre-Big Bang physics. Gravitational wave detectors probe the fabric of space-time itself for clues about its quantum structure. As you relax into sleep tonight, consider that the time you're experiencing may be more like a story your brain tells itself than an absolute feature of reality. The past exists as memories, the future as projections, and the present as an infinitely thin slice between them, a slice that quantum physics suggests might not even exist as anything more than a useful approximation. This exploration takes us to how these revelations about time's nature might transform our understanding of consciousness, free will, and the ultimate fate of the universe. Where time's greatest mysteries touch our most intimate perceptions of reality. As night settles around you and your breathing slows, consider this profound mystery. Your experience of time is being woven moment by moment in the loom of your consciousness. The steady tick-tock of clocks, the changing seasons, even the cosmic expansion of space-time, all these manifestations of time ultimately find their meaning in how they are perceived by a conscious observer. We have explored time as a dimension, a measurement, a quantum phenomenon. Now we turn to time as an experience, where physics merges with the intimate reality of being. Neuroscience reveals that our brains construct the experience of time through a symphony of interconnected processes. Unlike a camera capturing frames of reality, your consciousness doesn't perceive time in uniform slices. Instead, it creates time through a complex interplay of memory, anticipation, and sensory integration. The famous stopped clock illusion demonstrates this beautifully. When you suddenly shift your gaze to a clock, the first second appears to last longer than subsequent ones. Your brain has retrospectively stretched time to account for the eye movement, editing your conscious experience after the fact. The present moment you're experiencing right now, what William James called the specious present, is actually a constructed window spanning about 2 to 3 seconds. Your brain continuously stitches together sensory information with slight delays. Light takes time to hit your retina, sound waves need milliseconds to reach your inner ear, into a coherent now. This neural editing creates the illusion of simultaneity for events that actually reached your senses at different times. The smooth flow of time is, in truth, an elegant neural fabrication, a trick of consciousness that evolution found too useful to abandon. Time perception varies dramatically depending on state of mind. During emergencies, time seems to slow as your brain accelerates information processing and forms denser memories. In flow states of deep concentration, hours can feel like minutes. Depression can make time feel sluggish, while mania speeds its perceived passage. Psychedelic substances often induce profound distortions in time perception, with minutes feeling like eternities, suggesting that our ordinary experience of time is just one possible configuration of consciousness among many. This raises a profound philosophical question. If a tree falls in the forest with no one to hear it, does it make a sound? The quantum version might ask, without a conscious observer, does time truly pass? Some interpretations of quantum mechanics suggest that observation plays a fundamental role in reality's unfolding. The participatory universe hypothesis goes further, proposing that consciousness and physical reality co-create each other, with time emerging from this reciprocal dance. Your memories form the thread of continuity that we call our timeline. But memory is not a perfect recording. It's a reconstructive process that edits and rewrites the past with each recollection. The future exists in your mind as projections and simulations. The present is the vanishing point where these two mental constructions meet. In this sense, your personal experience of time is literally a work of fiction, an evolving story your brain tells to make sense of sensory inputs and internal states. The ancient philosopher Augustine wrestled with this paradox. What then is time? If no one asks me, I know what it is. If I wish to explain it to him who asks, I do not know. Modern neuroscience gives us new language for this mystery. Time is the brain's solution to the problem of organizing experience in a universe of entropy and change. Your sense of time's flow may be the most intimate illusion your consciousness creates. As you drift towards sleep, notice how your sense of time is already beginning to soften and stretch. The boundaries between moments blur. Thoughts float freely without the usual temporal anchors. In dreams, time becomes even more malleable. You can experience long, elaborate scenarios in mere minutes of REM sleep. This twilight state offers a glimpse of how fluid time perception truly is when freed from the constraints of waking consciousness. Have you thought about how these revelations about time might transform our understanding of free will, the nature of the self, and humanity's place in the cosmos? Next awaits the frontier, where physics, neuroscience, and philosophy converge, where time's greatest mysteries touch the essence of what it means to be human. As you settle deeper into the quiet embrace of night, let us contemplate the most profound mystery of all: how the shimmering illusion of time weaves itself into the very fabric of your consciousness. This is where abstract physics meets lived experience, where the cosmic dance of space-time becomes intimately personal. Your awareness right now, reading these words, feeling the rhythm of your breath, noticing the subtle weight of your body against the surface beneath you. All this exists in a fragile equilibrium between memory and anticipation, between what was and what might be. The present moment you're experiencing is not a fixed point, but a constantly shifting horizon, a wave crest between past and future that never actually arrives. Neuroscience reveals the astonishing mechanisms behind our temporal experience. Your brain operates on multiple clocks simultaneously, some tracking milliseconds for speech and movement coordination, others marking the circadian rhythms of sleep and wakefulness. The basal ganglia and cerebellum serve as precision timekeepers for physical actions, while the prefrontal cortex constructs the narrative timeline of your life story. But perhaps most remarkably, your brain constantly edits your perception of time after events occur. When you clap your hands, your brain backdates the experience, so the sound and touch appear simultaneous, even though the sound arrives milliseconds later. This postdiction means you're always living slightly in the past, your conscious present a carefully constructed illusion of simultaneity. The famous Libet experiments demonstrated that brain activity precedes conscious decisions by several hundred milliseconds. Your neurons commit to actions before you feel you've made a choice. This unsettling discovery suggests that our sense of volition may be a narrative our brains construct after the fact, like a sports commentator explaining plays that have already happened. Yet, this doesn't necessarily negate free will. It may simply mean that freedom operates on levels deeper than our conscious awareness, in the quantum fluctuations of neural processes we're only beginning to understand. Your memory plays even more elaborate tricks with time. Each recollection is not a playback, but a reconstruction, subtly altered by current context and beliefs. The more you recall an event, the more it changes. Your happiest memories gilded with nostalgia, your traumas either softened by time or sharpened by later pain. This malleability means your personal timeline is less an accurate record than an evolving story, edited continuously by the very act of remembering. Your sense of continuous identity across time, the feeling that you are the same person who went to sleep last night and woke up this morning, is a magnificent neural fiction maintained by this ever-shifting tapestry of memory. Meditation traditions have explored these temporal illusions for millennia. Advanced practitioners report states where the ordinary flow of time dissolves into what mystics call the eternal now, a boundless present that contains all moments simultaneously. Neuroimaging studies of experienced meditators show decreased activity in the default mode network, the brain system responsible for mind wandering through past and future. In these states, the usual mental chatter about what happened yesterday or what needs doing tomorrow falls away, leaving only pure awareness of being. Paradoxically, this timeless awareness often brings heightened sensitivity to each passing moment, like watching clouds drift across the sky without any urge to hurry them along or hold them back. Modern physics echoes these ancient insights in surprising ways. The block universe theory suggests that past, present, and future all exist simultaneously in a four-dimensional space-time continuum, our experience of time's flow being an artifact of consciousness moving through this eternal structure. From this perspective, your birth, your reading of these words, and your final breath all exist with equal reality in the vast, frozen landscape of space-time. Your consciousness simply illuminates one point along your world line at a time, like a flashlight moving through a darkened room. Quantum physics adds another layer of mystery. At fundamental scales, time may lose its ordinary meaning entirely. Quantum fluctuations happen outside our conventional space-time framework, and some interpretations suggest that quantum processes can even influence past events, as in the famous delayed choice experiments, where decisions made now appeared to affect what happened earlier. These quantum effects are normally confined to microscopic scales, but some theorists speculate that consciousness might amplify them, making our subjective experience of time a macroscopic quantum phenomenon. Your nightly journey into sleep offers a natural experiment in time's fluidity. As you drift through hypnagogic states, the usual rules of chronology dissolve. You might be simultaneously a child in one dream scene and an adult in another, with no awareness of contradiction. Lucid dreamers can sometimes manipulate dream time, experiencing hours of subjective time during minutes of REM sleep. Near-death experiencers frequently report time distortion, with comprehensive life reviews unfolding in moments. These altered states suggest that ordinary time perception is just one mode among many that consciousness can inhabit. The relationship between time and selfhood becomes even more intriguing when we consider developmental psychology. Infants live in an eternal present, only gradually developing the mental frameworks for past and future. Some neurological conditions can disrupt this temporal architecture. Patients with certain lesions lose the ability to place events in chronological order, while others become stuck in particular time periods of their lives. Your ordinary sense of moving through time is thus a hard-won neurological achievement, not a given. As you prepare to surrender to sleep, notice how your sense of time is already softening. Thoughts float freely without their usual temporal anchors. The boundaries between moments grow porous. In this liminal space, you're granted a nightly reprieve from time's relentless forward march, a reminder that your waking experience of time is just one possible configuration of consciousness among many. As we approach time's outer horizons, the universe itself keeps time through its grandest structures. Across the cosmic stage, celestial bodies move in rhythms so vast they make human lifetimes seem like the briefest flicker of a candle. Yet these astronomical clocks, from the steady pulse of pulsars to the slow waltz of galaxies, reveal time's fundamental nature as the universe's most patient metronome. Consider first the Earth's own motions. Our planet spins like a perfectly balanced top, completing a rotation every 23 hours and 56 minutes, a sidereal day, while simultaneously tracing an elliptical orbit around the Sun every 365.25 days. This dual rhythm creates the symphony of our seasons, the slow precession of the equinoxes completing its 25,800-year cycle with the precision of a celestial timepiece. The Moon keeps its own time, cycling through phases every 29.5 days, while gradually receding from Earth at 3.8 centimeters per year, a slow temporal dance that will continue until Earth's day lengthens to match the Moon's orbital period billions of years hence. Venture further into our solar system and discover more exotic timekeepers. Jupiter's Great Red Spot has been spinning for at least 190 years, possibly much longer. Saturn's rings showcase intricate wave patterns that mark time in millions of years. Pluto takes 248 Earth years to complete one orbit, its seasonal changes unfolding in slow motion across decades. These planetary rhythms remind us that time scales vary dramatically depending on one's vantage point in the cosmos. The stars themselves serve as magnificent clocks. Our Sun follows an 11-year activity cycle marked by sunspot variations. pulsars, the universe's most precise natural timekeepers, spin hundreds of times per second, their lighthouse beams sweeping across space with millisecond regularity. Some maintain stability rivaling atomic clocks. Variable stars, like Cepheids, pulse with periods precisely tied to their luminosity, allowing astronomers to measure cosmic distances across millions of light years. On even grander scales, galaxies rotate in stately fashion. Our Milky Way completes one revolution every 200 to 250 million years, meaning Earth has made about 20 galactic birthdays since its formation. Galactic clusters move through intricate gravitational dances spanning billions of years. The universe itself has a sort of heartbeat, the regular pattern of acoustic oscillations left over from the Big Bang, frozen in the cosmic microwave background like grooves on a cosmic record. Remarkably, we can use these celestial clocks to peer into time's deepest mysteries. The slowing of binary pulsar orbits provides indirect evidence for gravitational waves. The redshift of distant galaxies reveals the universe's accelerating expansion. Even the slight variations in Earth's rotation preserve memories of ancient earthquakes and ice ages. The cosmos remembers, and in its motions, we can read the story of time itself. As we prepare to understand time's ultimate fate, let these cosmic rhythms lull you into a state of wonder. The universe is alive with timekeeping of every scale, from the quantum vibrations of atoms to the slow turning of galaxy clusters. You exist at a privileged moment when consciousness has arisen to appreciate this grand temporal symphony, a fleeting but precious window in the universe's long journey from birth to dissolution. As we near the conclusion of our journey through time's mysteries across the universe and cosmos, let us turn inward to explore the most intimate dimension of all, how your own consciousness weaves the fabric of temporal experience. The steady tick of clocks and the cosmic dance of celestial bodies all ultimately find their meaning in how they are perceived by the human mind. Your experience of time's flow is not a passive observation, but an active creation, a masterpiece of neural artistry that transforms raw sensory data into the rich tapestry of lived experience. Neuroscience reveals that your brain constructs the experience of time through an intricate symphony of interconnected processes. Unlike a camera capturing discrete frames of reality, your consciousness doesn't perceive time in uniform slices, but rather as a fluid continuum shaped by attention, memory, and anticipation. The famous stopped clock illusion demonstrates this beautifully. When you suddenly shift your gaze to a clock, the first second appears to last longer than subsequent ones. This occurs because your brain retrospectively stretches time to account for the eye movement, effectively editing your conscious experience after the fact. Your perception of the present is not a direct reflection of reality, but a carefully constructed narrative, seamlessly woven together from sensory inputs that actually arrived at different moments. The specious present, that psychological moment you experience as now, typically spans about 2 to 3 seconds, though its duration can flex depending on circumstances. Your brain achieves this remarkable feat by integrating sensory information with slight but varying delays. Visual stimuli take about 50 milliseconds to process. Auditory signals require 10 to 50 milliseconds, while tactile sensations need 20 to 80 milliseconds. Rather than experiencing these inputs as staggered, your consciousness performs an extraordinary act of temporal stitching, synchronizing them into a unified present moment. This neural editing creates the illusion of simultaneity for events that actually reached your senses at different times. The smooth flow of time is, in truth, an elegant biological fiction. Your brain employs multiple specialized timekeeping systems operating at different scales. The basal ganglia and cerebellum act as precision chronometers for motor control and movement coordination, tracking intervals down to milliseconds. The suprachiasmatic nucleus in your hypothalamus serves as the body's master clock, synchronizing circadian rhythms with Earth's rotation. Meanwhile, your prefrontal cortex constructs the autobiographical timeline of your life story, weaving together memories into a coherent narrative of personal identity across years and decades. This multi-layered temporal architecture allows you to effortlessly switch between timescales, from the split-second timing needed to catch a ball to the long-term planning required to pursue life goals. The relationship between memory and time perception reveals even deeper mysteries. Each act of recollection is not a simple playback, but an active reconstruction, subtly altered by current context and emotional state. The more frequently you recall an event, the more it changes. Your happiest memories, gilded with nostalgia, your traumas either softened by time or sharpened by subsequent experiences. This malleability means your personal timeline is less an accurate historical record than an evolving story continuously rewritten by the very act of remembering. Your sense of continuous identity across time, the feeling that you are the same person who went to sleep last night and woke up this morning, is a magnificent neural achievement maintained by this ever-shifting tapestry of memory. Emotions dramatically alter your experience of time's flow. During moments of terror or crisis, time seems to slow as your brain enters hyper-awareness, processing information at accelerated rates and forming denser memories. In states of flow, during deep concentration or creative work, hours can feel like minutes as your self-awareness recedes. Depression often makes time feel sluggish and heavy, while manic states can create a sensation of time racing uncontrollably. Psychedelic substances frequently induce profound temporal distortions, with minutes feeling like eternities, suggesting that ordinary time perception represents just one possible configuration of consciousness among many potential states. The neuroscience of anticipation reveals how your brain constantly projects itself into the future. Your prefrontal cortex acts as a time machine that simulates possible scenarios, allowing you to mentally test outcomes before acting. This predictive capacity is so fundamental that much of perception is actually based on what your brain expects to happen next, rather than raw sensory input. When you hear a familiar song, your brain anticipates the next notes before they're played. When you see a friend's face, you recognize them before consciously processing all their features. This anticipatory mechanism means you're always living slightly ahead of yourself, in a world your mind has already simulated before sensory data confirms it. As you drift towards sleep, notice how your sense of time is already beginning to soften and stretch. The boundaries between moments grow porous. Thoughts float freely without their usual temporal anchors. In dreams, time becomes even more malleable. You can experience long, elaborate scenarios in mere minutes of sleep. This twilight state offers a glimpse of how fluid time perception truly is when freed from the constraints of waking consciousness. As your mind goes into deep sleep, wonder how all these temporal perspectives, from cosmic to personal, weave together into a unified mystery, ready to tie these threads into a comforting whole as you complete your journey into sleep. As our journey through time's many dimensions comes to its natural conclusion, let us settle into a space of quiet reverence for the profound mystery we've explored together. The story of time is not a linear path, but a vast interconnected web, from the quantum vibrations humming within every atom of your being to the stately cosmic dance of galaxies spinning through the void. As you lie here in this moment, between wakefulness and sleep, you exist at the perfect intersection of all these temporal scales, a living bridge between microseconds and millennia. Consider the miraculous journey that has led to this instant. The atoms comprising your body were forged in ancient stellar furnaces billions of years ago, their very existence a testament to time's patient craftsmanship. The calcium in your bones, the iron in your blood, the oxygen filling your lungs, all were created in the hearts of dying stars during epochs before Earth itself had formed. These cosmic ingredients have traveled through aeons to compose the temporary masterpiece that is you in this moment. Your every breath draws in molecules that once circulated through dinosaurs, through ancient forests, through the lungs of countless ancestors. Time's endless recycling of matter and energy made personal. The neurological processes creating your experience of this very moment are equally wondrous. As your eyes move across these words, electrical impulses race along neural pathways at speeds of nearly 300 miles per hour. Yet what you experience as instantaneous understanding is actually a carefully constructed illusion, a temporal mosaic assembled by your brain from sensory inputs arriving at different speeds. The sound of these words, the feel of your bedding, the memory of today's events, all are being woven together into your subjective present by a brain that constantly edits reality to create the smooth flow of time you take for granted. Yet we've seen how this flow is anything but absolute. Time bends around massive objects in space, slows down at tremendous speeds, and may lose all meaning at quantum scales. The present moment you experience is both impossibly brief, lasting perhaps just a few seconds in conscious awareness, and infinitely deep, containing echoes of the universe's entire 13.8 billion year history. Your perception of time's arrow, always pointing forward, emerges from the increasing entropy of countless quantum interactions, each like a grain of sand falling through the cosmic hourglass. As sleep's gentle tide washes over you, consider how your dreams will soon demonstrate time's fluid nature. In the dream state, you might experience days or years in mere minutes of REM sleep, converse with long-gone loved ones, or visit impossible landscapes that defy physical laws. This nightly journey proves that your brain can construct entirely different temporal realities when freed from sensory constraints. The same neural mechanisms that create your experience of time while awake become unshackled in sleep, revealing time's fundamentally subjective nature. The great mystics and physicists alike have pointed toward this truth, that all times may coexist in some deeper reality beyond our ordinary perception. Just as a piece of music exists whole and complete, even as we experience it note by note, your life may be part of a greater pattern that transcends linear time. The past is not gone, but preserved in the fabric of space-time. The future not unformed, but potentially existing as part of time's full spectrum. Your consciousness, normally focused on the narrow band of the present, may in sleep or meditation touch this more expansive reality. As you surrender to sleep tonight, imagine yourself floating in time's river. There's no need to swim against the current or grasp at passing moments. Like a leaf carried by gentle waters, you can trust the flow that has brought you this far. The same forces that keep planets in their orbits and stars burning bright also maintain the perfect rhythm of your heartbeat. The universe that birthed galaxies also shaped the neural pathways now softening into sleep. Let your breathing slow to match time's patient rhythms. With each exhalation, release any tension about time's passage. With each inhalation, draw in the peace of knowing you are exactly where and when you should be. The day's worries and tomorrow's plans can wait. This moment contains all the time you need. As consciousness begins its nightly retreat, remember that time is both your companion and your creation. The cosmic timeline stretching back to the Big Bang and the personal timeline of your memories meet here in this quiet space between thoughts. The quantum vibrations underlying all matter and the neurological processes shaping your experience are partners in time's eternal dance. Sleep now, dear traveler through time. Let your dreams carry you beyond ordinary temporal boundaries. The universe will keep its ancient rhythms until morning. Stars will continue their slow burn, atoms will maintain their quantum dances, and time itself will hold you gently in its care. When you awaken, you'll return to time's measured flow, but part of you will remember that deeper reality where all times are one. Good night, and may your rest be as timeless as the cosmos itself. The story continues, and you are both its witness and its living word. Sleep peacefully in the arms of eternity.